Now, the calculation I'm going to do in chemistry will be a simple, straightforward one. Things like I will give you what I'm using in chemistry. I'll be thinking like maybe 2 pens, 12 pens were bought for maybe for 60 naira. Or let me use dollars. Were bought for $60. What will be the cost of 17 pens? I'll just call it X. Do you get what I'm doing for you? When it was 12, it was 60. Now that it is 17, what will it be? Well, how do you get X out of here?
We say 17 over 12 times 60.
17 over 12 times 60. That's correct.
Mm-hmm.
So just be what? 17 times 60 over 12. Do you agree? The same thing.
Yes.
So this is what I will not use complex. If you can know this, then you can know the calculation in chemistry. I will not use any complex calculation for you. This is all you have been using for you. Is that okay?
Yes.
Now, I don't have note on this. I have no chemical bonding, state of matter. I've told that about 75% of the note I have. This one is calculation. I don't know how to form notes on it. So I will teach you this topic under maybe 30 minutes of 1 hour. Maybe 1 hour I will go to solve question. I cannot teach you this topic except I solve question for you. So it's not about it, it's about solving questions. Do you get?
Yes.
So atoms, molecules, this. So when we say relative, there's an atom we used to compare every other atoms. So relative atom, reference atom for masses. Reference atom for measuring masses. For measuring masses is what? Is carbon 12 isotope. Am I right? It's a reference. It's a reference for measuring that thing. What is the reference element for measuring reactivity?
Reactivity.
Reactivity. You did it in GCSE. You didn't explain to you that way. Reference element for measuring reactivity. You know reactivity series?
Yes, I'm familiar with it.
So which element is that? You say some elements are above this, some are below this guy. There's a guy you normally mention. Some elements are above this guy, some are below him. Which element is that?
Is it magnesium?
No, it's not. It's a non-metal. And sometimes it behaves like metal. It loses electron, yet it's a non-metal. It's between metal and non-metal. Which element is that? It's a non-metal, but it loses electron as if it's a metal.
Potassium.
Now, I'm going to ask you last time. Which non-metal is formed at the cathode? The only metals are formed at the cathode during electrolysis. There is only carbon cannot be formed electron. Carbon don't lose electron, don't get electron. There's an element that is a non-metal and is formed at the cathode. Which element is that? A non-metal formed at the cathode during electrolysis. There's only one. A non-metal. A non-metal, it is formed at the cathode. It's formed positive and it gains only one electron. Do you remember hydrogen? Hydrogen.
Oh, hydrogen.
Hydrogen is a reference element for measurement of reactivity. It's a reference. So reference element for measuring reactivity is what? Is hydrogen. Is that okay?
Yes.
For measurement mass is what? Is carbon 12. Is that okay? Good. Now let's go. Now, how do we define this? Let's go back to the syllabus. Number one, can you read number one?
Define the unified atomic mass unit as 1/12 of the mass of the carbon-12 atom.
Can you explain that to me? Take your time. Don't rush. Take your time to relax. Yeah, explain what does it mean? What's unified atomic mass unit? How do you find it?
Atomic mass unit.
We find the mass of carbon 12 atom and we divide it by 12. Do you agree?
Yes.
Mass of carbon 12 atom, then 1/12 of it divided by 12. Do you agree?
Yes.
So let's go and find it. So we are going to unified atomic mass unit. Unified atomic mass equal to mass of one atom of carbon 12 over what? Over 12. Do you agree? That's it. Is that okay? So how do we find it now? Yeah. How do we find the mass of one atom of carbon 12? Yeah, we start like this. Pay attention though. 1 mole of carbon 12. What's the mass? Is 12 grams in your periodic table. All this mass they wrote here is from 1 mole. Look at these masses. Where is my periodic table? This mass I want to show you, therefore 1 mole. Look at it. We are saying that, please, we are saying that 1 mole of carbon has a mass of 12. 1 mole of nitrogen, a mass of 14. 1 mole of oxygen, a mass of 16. 1 mole of fluorine, a mass of 19, etc., etc. Do you get the point now? So the masses put here is the mass of 1 mole. Please, what does 1 mole mean in GCSE? How many atoms are in 1 mole? How many particles are in 1 mole?
1.62 times 10 to the power 23.
Say that again.
1.62.
Who told you one? I mean 6.02. Yeah, let me show you. You don't have to memorize it. They give you the exam. Yeah, look at it. It was Avogadro constant. Yeah. Is it 1.6?
6.02.
I know you know it, you just missed some. So this is the number of atoms. Can you see? 6.02 10 per 23 per mole. That's the number of particles in 1 mole of every substance. Is that okay? So now let's go on. So 1 mole of carbon 12 is this. What does 1 mole mean? 6.02 times 10 to the power 23 atoms of carbon 12. What's the mass? 12 grams. Do you get? 1 mole of carbon 12 means that number of atoms. How do you find the mass of 1 atom now? Let's now go and do 1 atom of carbon 12. Let's call it X. Can you find your X? That number of atoms of carbon 12 is 12 grams. So what's now the mass of 1 atom of carbon 12? Our X should be what? Should be what?
We'll say 12 divided by 6.
Now you are talking. So 12 divided by 6.02 10 to the power 23. This is gram. This is atoms. So what will it give you? So gram per atom. Am I right? What do you get? What's the value?
1.99 times 10 to the power 23.
Gram per atom. That's the mass. So this is the mass of 1 atom of carbon 12. Do you understand that? This is the mass of 1 atom of carbon 12. Can we now find? Therefore, unified atomic mass unit. Unified atomic mass will be what? 1.99 10 to the power 23 over what? Divided by 12. What do you get?
1.66 times 10 to the power
1.66 10 to the power
22.
22. Actually, it's 22.
Yes.
Hope you have not made any mistake here. Okay, it's okay, it's correct. Gram. Is that okay?
Yes.
I convert that to kilogram.
Divided by 1,000.
1.66
times 19.
Is it 19 or minus 23? You are missing. Go and start again. You made me. That thing should be 1.99 10 to the power minus 23. Not 23. Minus 23. Check your calculator well.
Okay.
Am I right?
1.99 times 10 to the power minus 23. Okay. Divided by
minus 19 kilogram now. This is unified atomic mass unit.
So divided by 12, it gives us 1.65. 1.66 times 10 to the power negative 24.
20 what?
24. Negative 24, not 22.
Okay. Negative 24. I'll show you about that. Okay, hold on. Hold on. Okay, minus 24. Are you sure?
Yes.
Okay. Then divide by 1,000. What will it give you? Minus 27. Thank you. You are right.
Yes.
Is it correct now? Check it out.
Yes, it is.
Good. Can you see now? This is the relative. So come and see your data booklet. Come and see. Let me show you your data booklet. They didn't put in data booklet, but they put mass of proton. One way is a little bit more hard than it. Is that okay? Or they didn't put it here. This is proton mass of proton. Mass of proton is 1.67, but the other one is 1.66. Is that okay? If you look at it, it's in physics textbook. They put in physics textbook. They didn't put it here. Anyway, that's the unified atomic mass unit. Is that okay?
Yes.
Mass of one atom of carbon-12 divided by 12. That's the simple way of saying. Is that okay? Mass of one atom of carbon-12 divided by 12. That's the simple way of saying it, and that makes it clear. I'm sure that makes sense. That's how to go. So that's our reference mass. Is the one we use to compare other masses. Is that okay? Is a reference mass. Is that okay? So now
Yes.
we have to define some things now. Look at number 2. Can you look at number 2?
Define relative atomic mass, AR, relative isotopic mass, relative molecular mass, MR, and relative formula mass in terms of the unified atomic mass unit.
Good. So this is how we say that. It's simple. So relative mass is number 1. Relative atomic mass is for an atom of an element, and most elements exist as isotope. So you call it, so it's the weighted, this guy, AR, capital A, not argon, no, capital A, subscript R, do you get?
Yes.
Is the weighted average mass. Weighted average. What am I weighted average? Because all the isotopes, they don't all have the same percentage contribution in the atom. Some isotopes have high values, so it's the weighted average mass. Weighted average mass. Is that okay?
Yes.
Weighted average mass of the of one of atom of one of an atom of an element, of an atom of an element. I've not completed the meaning one. Oh. Number 2, relative formula mass. Or let me do molecular mass first of all. What's a molecule? You know what? How do you define a molecule?
A molecule is a substance made out of the same kind of atoms.
It doesn't have to be. Are you sure? Are you sure the same kind of atom? Molecular mass is the weighted average mass of one molecule. Is the weighted average mass. Don't worry, I'll teach you how to remember it now. Okay. Of one molecule. Number 3, relative formula mass. I'll teach you how to remember it. Let me done. Is the weighted average mass of one formula unit. Weighted average mass of one formula unit of an ionic compound. Of one formula unit. I will explain to you. Don't worry, just let me do done. Formula unit of an ionic compound. And finally, number 4, relative isotopic mass. This is also MR. Relative isotopic mass is the mass of a particular isotope of an element. All of them, I didn't complete them all. All of them compared with unified atomic mass unit. So let me go. What is relative atomic mass? Is the weighted average mass of an atom of an element compared with unified atomic mass unit. Relative molecular mass is the weighted average mass of one molecule compared with unified atomic mass unit. Relative formula mass is the weighted average mass for one formula unit of an ionic compound compared with unified atomic mass unit. Relative isotopic mass is the mass of a particular isotope of an element compared with unified atomic mass unit. Let me learn. Look at this. O, CO2. Let me start again. Let me do like number 1. When we say relative atomic mass, we are talking that a single atom, O, Mg, S, Br, Ca, S, P, H. Is that okay?
Yes.
And sometimes when they are in ionic form, you see the same thing. Because whether an atom or an ion, the mass of electron is so negligible that we can't really reckon with it. Do you get? Whether it is O2 minus, it's still atomic mass. Is that okay? Whether
Yes.
it's Mg2 plus, it's still what? Atomic mass. Is that okay? You don't say ionic mass, it's still atomic mass. Do you get?
Okay.
Sulfur is still atomic mass. Br minus is still atomic mass. Al3 plus is still atomic mass. Do you get the point now?
Mm-hmm.
Am I done? Number two. Number one is relative atomic mass. Number two is relative molecular mass. Look at it. I've numbered it here. Number two, molecular
Okay.
mass. What's a molecule? A molecule is a group of atoms covalently bonded together. The
Mm-hmm.
atom may be the same type or different type. Therefore, a molecule can be a compound or can be an element. I'll quickly write that down. A molecule consists of group of what?
Atom.
Have a private tuition? Don't you have? Do you have? And yes, Gel Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE. And yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have
Okay, a molecule consists of group of atoms which are covalently bonded together, together. Give an example. It can be same atom. Cl2 is a molecule. H2 is a molecule. N2, O2, Br2, F2, I2. Ozone is a molecule. Phosphorus is a molecule. S8 is a molecule. C60 is a molecule. C90 is a molecule. C120 is a molecule. Do you get the point now? All of these are molecules. Do you get?
Yes.
They are all non-metal bonded. So a molecule is a group of non-metals actually. Some that can be metal, but most of them are non-metal, which are bonded by covalent bond. Do you get the point?
Mm-hmm.
These guys are elements. So molecule can be elements. Can we also have molecule that are compound? Yes, water is a molecule. Carbon dioxide is a molecule. Ammonia is a molecule. SO2 is a molecule. SO3 is a molecule. Methane is a molecule. All organic compounds are molecule. All organic compound because they are all non-metal. All organic compounds. All organic compounds are what? They are compound, are molecules also. So a molecule consists of group of atoms which are bonded by covalent bond. Is that okay?
Yes.
Good. So MR, we use MR for all these guys here. We don't say molecule. Pay attention. Number one is atomic mass. Am I right? We say relative atomic mass of oxygen, relative atomic mass of magnesium, relative atomic mass of sulfur. Is that okay?
Mm-hmm.
I can say relative atomic mass of chlorine. That's I'm thinking about a single chlorine atom. But when it's chlorine molecule, it is now relative molecular mass. Is relative molecular mass, not atomic mass. It's a molecule. Hello, what about this guy? Relative what? Atomic mass. Relative
Atomic mass.
atomic for atoms or ion for a single atom.
Mm-hmm.
Atomic mass. What's third one? What's third one? Number three is what? Relative what?
Formula mass.
That's for ionic compound. We don't say molecular mass of sodium chloride. It's not correct. No, it's
Okay.
represented with MR and it's called relative formula mass. Relative formula mass. This is for ionic compound like magnesium oxide, calcium chloride, sodium carbonate, copper sulfate, aluminum oxide. Is that all these? Anything ionic, they fall here. So potassium iodide, barium what? Barium sulfate, aluminum nitrate. All those are ionic compound. We don't say relative molecular mass of sodium chloride. It's not correct. What do we say? Relative formula mass. Do you get the point?
Mm-hmm.
Am I
Okay.
complicating? we don't say relative molecular mass for sodium chloride. It's not correct. It's like calling a boy a girl. You say relative formula mass of sodium chloride. Relative molecular mass for molecules. Relative atomic mass for single atoms or their ions. Then now, finally now, number 4, relative isotopic mass. Now, come back here. When we say relative atomic mass of oxygen, which oxygen are we referring? Are we referring to oxygen 16, oxygen 17, or oxygen 18? Which one are we, when we say relative atomic mass of oxygen, which of the oxygen are we referring to here? All of them combined.
Okay.
But that's why we say it is weighted average mass of all of them. Do you get the point now?
Yes.
So atomic mass is for all the isotopes of oxygen that ever exist in life. Do you get the point now? Come back here. So relative atomic mass is the average mass of an atom. I will say it in another way. This that's the way to say it. We can say is the weighted average mass of all the naturally occurring isotopes of an element. Do you get the concept now? It actually means weighted average mass of all the naturally occurring, all of them combined. That's why we say weighted average mass. They don't all have the same percentage. We say weighted average. Is that okay? Weighted.
Yes.
It's like saying you want to share the money you want to share the money in a particular town, and male and female are not the same number, so you can't just share the money to half. Female take half, male. You can't do that. You'll be wrong. Maybe there are more males than female. You can't just say female take half of the money, male take. You can't say that. That'll be wrong. The question is this: what is the percentage of male in that country? 60%. They had if you want to share it equally, it should not be money allotted for male will now be 60% of the total that they have. Is that okay? That would be a weighted average. Is that okay? Weighted average. Is that okay?
Yes.
It should be average. So based on their percentage, you can't just say the share it 50-50. It shouldn't be fair. You get it? It shouldn't be fair. So same thing with this one. So when we say relative atomic mass of oxygen, we are referring to all the isotopes of oxygen. Do you get the point now? Combined together. Do you get?
Yes.
Then we now come here. We can be talking about a particular isotope of oxygen, not all of them. Oh, what is atomic mass of oxygen 16? Relative atomic mass, relative isotopic mass of oxygen 16. Relative isotopic mass of oxygen 17. Can you now? This one is for a particular isotope. Is that okay?
Yes.
Therefore, in the definition, do we need to say weighted average or not?
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable and you get the very best of service. We also have for the E-levels as well, and also for the EdExcel. So we have for the Cambridge E-levels and EdExcel E-levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E-level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E-level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you. And the good news about this is, what I've discussed with the sales team is, we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Agile Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So again, what are you waiting for? Just send an email to the sales team. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2025, watching this in 2026, watching this in 2027, we're currently ongoing, and this is actually a good time for you to actually explore and then get it tailored to your own needs. So trust me, you don't want to miss out.
To define relative isotopic mass, we have to use the word weighted average or not?
It's not the average, it's just of one.
Thank you. Can you come and see now? Come and see the I said relative isotopic mass is the mass. I didn't say weighted average. You can't use weighted average for isotopic mass because it's for a
Yes,
particular isotope. You are not finding the average of anybody. Other
just
one are
one.
weighted average. Oh, atomic mass, weighted average mass. Molecular mass, weighted average mass. Formula mass, weighted average mass. But this guy is just the mass. It's not weighted average. The mass of a particular isotope you are referring to. Which isotope are you referring? Are you referring to oxygen 16, 17, or which one are you referring to? That's for isotopic mass. But when you just say oxygen generally, that's for atomic mass. Do you get the point? When you say oxygen generally, atomic mass. So I'm going to do something for you now. Example of this now. Let's say example of this will be what? Will be things like carbon 12, relative isotopic mass of carbon 12, of carbon 13, of carbon 14, of oxygen 16, oxygen 17, oxygen 18, magnesium 24, magnesium 25, magnesium 26. Can you see now? We are particularly by the, so it's not weighted average. It's for, it's just, you can say relative isotopic mass of oxygen 18, of carbon 14. You know, do you get the concept now? So let's go now. Look at this. O2 plus, O2 minus, O, 16O, 18O2 minus. Yeah, which one apply to this? William, which one will I use relative atomic mass for here? Which one will I use relative atomic mass for here? Among these four guys I wrote, yeah, tell me. Relative atomic mass. This one is atomic mass, am I right? Relative atomic mass. Do you agree?
Yes.
This one also is what?
Relative
atomic mass. Do you agree? Is that okay? And this one also
relative
atomic mass. Atomic mass. What about this the first one here? Molecular mass. Am I right? Because it's
molecular mass 2, yes. O2.
Exactly. Molecular mass. Well, that's all. Is that okay? What about these other two guys? Isotopic mass. Am I right? Or you were specific? You said oxygen 16. This one also
18.
Isotopic mass. Do you know the difference between three of them now? You see the,
Yeah.
so atomic mass is for an atom or the ion of that atom. Atom or the ion of that atom. Molecular mass is for a molecule or the ion of that molecule. The isotopic mass is for a particular isotope or the ion of a particular isotope. Is that okay? Does it make any sense here?
Yes, it does.
So, yeah, define for me what is relative atomic mass
Relative atomic mass is the weighted average mass of an
of an
atom.
atom compared with what?
Compared
Unified
with the carbon, with the
atomic
unified
mass unit.
mhm,
What about molecular mass?
weighted average mass of one molecule compared to the unified
Atomic mass unit.
atomic mass.
Unit compared to unified atomic mass unit. What about formula mass?
Weighted average mass of one formula unit
Of an
of
ionic
an ionic
compound.
compound
Compared,
compared to them.
good. And finally, atomic mass.
It's the mass of a particular isotope of an element
Oh,
compared with the
I didn't say that. I should have said is the mass of one atom of one atom. It should be of one atom. I didn't put the one atom there.
Okay.
Is the mass of one atom of a particular isotope of an element compared with what? Unified atomic mass unit. Is that okay? We are done with that. We are done with these two. The next one, mole and Avogadro's constant. What's mole? In terms of Avogadro's constant, what's mole?
Define. Am I reading the?
Yeah, what is mole? We are here now. What is mole? I'm saying define mole. What's mole? What is, you have done energy sense. What's mole? Just say 1 mole of a substance. 1 mole of a no story there. 1 mole of what? Of a substance is the amount that what? That contains Avogadro number of particles. Is that correct? That's how to define no story. 1 mole is the amount that contains Avogadro's number of particles. That number, how big it is?
6.02 times 10 to the power 23.
How big it is? The people living in the world, are they up to this?
Sorry?
Or the population of the world, is it up to this number?
No.
What about the people that have ever lived since the world began?
It's way too big.
People that have ever lived since the world began, that will continue to live in the world for the next 1 million years, can be up to this.
Yes.
This number is big. You know how big it is?
Yes.
It's big. You can only imagine it. It's too big. The meaning is this: an atom, though. Now look at it now. You said that. Look at the mass of one atom of carbon 12. One atom of carbon 12. What's the mass? What's the mass of one atom of carbon 12? What's the mass?
1.99 times 10 to the power 23.
If I throw 10 billion atoms at you, you won't feel it. If I carry 10 billion atoms and I feel it, I throw it at you, you know something touched you. What does that mean? An atom is so small that you can only imagine it. If I carry 10 billion atoms and throw it at you, you won't feel it. You know something touched. So you know how tiny it is, so tiny that it can only be imagined. Do you get it now? 10 billion and 10 billion and 10 billion of atom. You throw it at you, you won't feel it. Now let's see. I want to show you something. I will write for you the molecular mass of you are doing biology, right?
Yes.
Good. I'll write for you the molecular mass of hemoglobin. Now you're going to interpret it for me. I don't know what it means. When last did you check your mass? I want to drive home a point.
When last did I check my what?
Your mass.
My mass, not so long ago. It's
What do you weigh?
54.
54. Okay, good. That's good. Let me land. You said you weigh 54 kilograms. Now, let me now show you what hemoglobin is. Hemoglobin molecular formula is so big Regular formula. This is hemoglobin. The one, thank God you're a biology student. The hemoglobin is C29H, no, C2952, H4664, N832,
Hmm.
N, no, am I right? Please 1 minute. N3248, N3248, 3248, OH12, S8, Fe4. Look at hemoglobin. This is hemoglobin.
Mm.
Now, if you calculate molecular weight of hemoglobin, it should be. I don't want to calculate it. I don't want time. It should be doing carbon times 12. We don't have time. Let me just check the value in online. Molecular
Okay.
weight of hemoglobin to save our time. Molecular weight. I want to drive home a point. I'm going to ask you of what? Hemoglobin. Molecular weight of hemoglobin. The value is there is did you give me in gram now? That is about 65,000 grams per mole. What does that mean? 65 kilogram per mole. Do you have hemoglobin in your blood?
Yes.
And we are now, so how do you reconcile this? You are not even up to 65 kilogram, and yet hemoglobin is 65 kilogram. How do you interpret it? You weigh 54, and you say hemoglobin is 65,
65.
and you say you have hemoglobin in your body. How do you interpret? You interpret it for me. I don't know how to say that. It doesn't just make sense to me. You weigh 54, hemoglobin weighs 65, and it's in your body. Hey, yeah, interpret for me. I'm listening. Yeah, but thank God you're a biology student.
That's what hemoglobin weighs, but it says per mole, so
Yeah, go
maybe.
on. Yeah, you're making sense. I'm listening. Go on. What does that mean? Suppose I don't know chemistry and you won't tell me what this means. I say, how can you say hemoglobin is 65 and you are not even up to 65 and you say you have it in your body and I don't know chemistry? How will you explain to me? I'm a layman. I don't know chemistry at all. What will you tell me? Hemoglobin has a mass of 65 kilogram per mole. You have
Mm-hmm.
it in your body and you are not even up to 65. So yeah, interpret for me. I don't know. I want to make chemistry that chemistry can make sense to you. I don't want to just learn chemistry. I want to know what it means. You realize I can interpret, you can apply it. You need to solve the exam question and you will pass it very well. Do you get? I'm listening. What does it mean? The only way to interpret that you don't have up to 1 mole in your body. Do you agree?
Yes.
That's the way to interpret it. There's no way to interpret it. What that means is this. You are saying that 6.02 10 to power 23 molecules of hemoglobin is 65,000 grams.
Mm-hmm.
That means, let us assume that, okay, let's check it online. Can you check something online there?
Okay, yes, I can.
Can you check that an adult human being, how many molecules of hemoglobin will they likely have in the body, in the blood? An adult human being. What is the approximate
How
number of
many
hemoglobin?
molecules of
Approximate number of
how many?
hemoglobin. Just say approximate number of hemoglobin present in an adult blood. Mo dẹ̀ sọ pé mo jùlọ bẹ́ẹ̀ gbọ́n ẹ̀jẹ̀ bẹ́ẹ̀ gbọ́n wà bí.
What did she tell you?
Kí ló ń fún ẹ?
Chicken your heart surface.
Mo sẹ́ni already ẹ̀kọ́ mi wá fún ọ̀dọ́ mo sẹ́ni already yìí. Bá ti lè ojú sọ́dọ̀ ẹ̀. Wọ́n ti ní my document láti ṣe àforúkọ ẹ̀ síbẹ̀. Mo ń lọ bẹ́ẹ̀ gbọ́n lẹ́ẹ̀kan. Resend there kò fi sọ bẹ́ẹ̀ sí. Please, time more than 1 minute, please.
Okay.
Yeah, ẹ máa ṣe bẹ́ẹ̀ yẹn náà ló ṣe mí dání kẹ́ ẹ máa kọ́ mi.
Ọmọ ìwà kíláàsì.
Yeah, okay.
Ìwádìí gbélé yìí compose. Image ìtumọ̀ ẹ̀ lè subject. Olusegun Jimmy to document Olusegun Abiola. document. Composing. Good morning, I hope this meets you. Good morning. Good morning, madam. Madam, good morning. What is the vision of your voice? I hope this meets you well. Please find the attached document. But the people speaking over the send it containing my setting. Ṣé máa tàṣe mọ́ ni? Other documents. Wọ́n ti ní mo máa ń ṣe nǹkan. A lè wà ní bí o lè rẹ́ sẹ́ndẹ̀ ohun púpọ̀ ní èkó. Ìdílé fíìmù ìwà sí ìdílé bí fáìlì ló wà fún ìwọ̀n lọ sí ìdílé ìwà ìsìnkú ìdílé. Ìwé ọdọ́ pèsè ìdílé ní o tẹ̀lé kí ìdìbò fẹ́ máa mú ọgbà máa mú ìjọ́dá tó fẹ́ mi. Orí mi tí mo lọ. Àwọn báwọn tó wà lè máa tó pété mo ṣe báyìí. Ìwádẹ̀, thank you, Ìwádẹ̀ send this. I'm back. What did they say? What is the answer?
About 270 million hemoglobin molecules.
Thank you. 217 million hemoglobin molecules. Yeah, let's go and do that. So 217, that was 217 times 10 to the power 6 molecules.
270.
270.
Yes.
270 million. 270 of hemoglobin will be what? X. Can you find the mass?
Okay.
X, my mass will be what now? It will be 270 million times 5,000 over what? 6.02 10 to the power 23. Yeah, what do you get? This is the mass of all the hemoglobin. If you have 270 million hemoglobin in your body, this is the mass. You have, what do you get?
2.92
times 10 to the power minus
34.
Minus what?
34.
No, it can't be. You didn't do it well. It can't be. No, you didn't do it.
Let me do it again.
I hope you press your calculator well. Let me do it here myself. I don't have a calculator. I can use my phone. Choose.
Thank you.
Should you send it? What you attach it with? Race of you NYC. Oh God, thanks. But let's get another document. Olusegun bracket applicant for teacher. Applicant. Tamuna, 1 minute, please.
Okay.
And applicant to applicant. I mean, my English. Applicant as a teacher, teacher's applicant to engineering school. What my means in my body by what obviously. The applicant, teacher's applicant to engineering school. Get by a call. My dad female says, I'm back. What do you get?
I'm still getting the same, and it's not a negative. It's giving me a positive power.
Negative. It should be negative because 23 is bigger than 3. Now, that means you're. I have to really times. Hold on, let me do it on my phone here. It will not work. Oh, yes. Multiply by 65,000, then divided by 6.02. 6.02 times 10 raised power of. Raised power of. Okay, I got it. I got 23. I'm using my phone. Okay. Hello, your calculator, how do you do it? 270 times 10 raised power 6 is equal to multiply by 65,000 is equal to, make sure you make it, if you want to press on your calculator, hello, are you listening to me? You have to put these two in bracket. If not, or you first say equals to, now do it again. You need to get the answer. Go back to your calculator. Put those two in bracket.
If I multiply the top, I get 1.755 times 10 to the power 13.
Now, divided by this now. You get the answer now. Yeah, divided by the numerator now, yeah.
Okay. Oh, okay, I got it. Times
You
10
minus.
to the power negative 11.
What 2 point what?
2.92.
Negative 11 grams.
Yes.
Can you see how tiny it is?
Yeah, it's tiny.
All hemoglobin you have in your body is not up to 1 gram. Can you hear that now? You have 270 million hemoglobin in your body. Suppose all of them together is not up to 1 gram. Can you see how tiny hemoglobin is? Can you see how tiny it is? It is infinitesimally small that your mind cannot imagine it. We calculated the mass of 270 million hemoglobin. It is not up to 1 gram. Tamuda, do you understand what that means? It's not up to 1 gram. So a molecule is so small. So that means if they throw 10 billion hemoglobin at you, you won't feel it. Do you agree? It's not up to 1 gram. It's not tiny 1 gram is. 1 gram is so small, yet 270 million hemoglobin is not up to 1 gram. Imagine that. So I want to understand this calculation based on this perspective. Atoms in chemistry are so tiny and so small. When we say 5 grams of atom, we are talking about billions and billions and billions and billions atoms. Because the atom is so small. Now look at this whole thing. Look at this whole thing. Look at how big it is. This whole thing. This whole thing. 270 million of this thing is not up to 1 gram. Imagine. Now, when you now consider carbon dioxide, that one is so small. That one is even nothing. So when you breathe out once, you breathe out carbon dioxide, you release billions of molecules of carbon dioxide. Billions. You get now. So it's so small. I'm just trying to tell you how tiny and how small a molecule is. Do you understand what I'm trying to tell you now? You have hemoglobin in your body, but you don't have up to 1 mole. Even if you have 10 trillion hemoglobin in your body, it's not up to 1 gram. Imagine. That's God is too much. Do you get now? So that's just how it goes. Am I communicating now? So you understand this concept now. So when we say carbon dioxide is 44, what does it mean? Carbon dioxide is 12 plus 16 times 2. What does it mean? 44 grams per mole. What is the mass of 1 molecule of carbon dioxide? How do you find that? So this is the mass of 1 mole. Amanda, is it not one mass of 1 mole per mole? What is the mass? What is the mass of 1 molecule of carbon? How do you find that? How do you find that?
We say if 1 mole,
which means 6.02 10 to the power 23 molecules is equal to 44 grams. So one molecule therefore is X. My X will be what? 44 over 6.02 10 to the power 23. What do you get?
Times 10 to the power 23.
No mistake this
We
time.
get,
No mistake this time. No mistakes.
okay. We get 7.31 times 10 to the power negative 23
23 gram per molecule.
gram per molecule.
Can you now? So can you see how tiny it is? So if
Yes.
somebody, if you, so my point is that the CO2 you are bringing out of your nostrils that you can feel when you breathe there, you can feel the impact on your hand. There are billions and billions and billions molecules there, billions of them, uncountable. Do you get the point now? It's too much. So a single molecule is so small that you can only imagine it. You can't separate it. You can't have a single molecule on your own. You can't have it. You can't separate it because it's so small. Not that, listen very well. Not that a molecule of sodium is invisible. It's a visible thing, but it's too small to be seen by our naked eyes. When a microscope take an atom of sodium and magnify it a billion and a billion and a billion times, you may not still be able to see it. It's so small that you can only imagine it. Do you get the point? And experiment has proven that those things are real. No, they are not just imagination, they are real. They are real. I'm telling you, they are real. Because based on those fact and figure, they manufacture drug. When you have malaria, you will take those drugs and you'll be fine. So those things are real. They are not just imagination, they are real. So science is real. Science is not imagination, it's real. Only that for you to comprehend science, you must know how to imagine things. Do you get the point now? We need to come down to atomic level and say, okay. So when you have it now, if I'm asking you now again, if I say a drop of water, how many molecules of water do you think is in it? Just a single drop of water. How do you find the number of molecules in a single drop of water? How do you find the number of molecules in a single drop of water? Can
We
you
have to get the mass of H2O.
uh-huh. Now listen very well. I do this. Look at this. Now this is a burette now, right?
Yes.
Thank God. I want to know this science so that when I'm teaching the calculation, you will be able to comprehend it faster. A burette. This place is 40. Suppose it's 40. This place is now 41. Am I right?
Mm.
I'll place a conical flask here. I'll open the tab so small that it come in form of drops. Is that okay?
Yes.
I will run it from 40 to 41. I'll now count how many drops did I produce from it. Is that okay?
Mm-hmm.
I run it from 40 to 41. How many cm cube is that? That is 1 cm cube, right?
Mm-hmm.
Maybe I now got in that one, maybe I got like maybe 85 drops in 1 cm cube, right?
Mm-hmm.
Are you listening to me? I got 85. Suppose I opened a bread from 40 to 41. It's coming out in form of drop. Pam, 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 pam. And I count the number of drops produced. Produce what? 85 drops in 1 cm cube. So how do I find the mass of that? That means mass of one drop. What's the volume of one drop now? Or let's just say 1 cm cube. But density of water is what?
Mass of
Density of
uh,
water is 1 gram per cm cube. That is 1 gram of water has a volume of 1 cm cube. 1 gram of water has a what? Has a what?
1 gram of water.
Has a volume of 1 gram per cm cube. What does it mean? 1 gram per cm cube. What does it mean? 1
1
gram of
gram.
water has a volume of 1 cm cube. Do you agree?
Yes.
1 gram of water has a mass of 1 cm cube. So what's the mass of 1 cm cube therefore is 1 gram. Do you agree?
Mm-hmm.
1 gram. So you are saying that 1 gram is what? How many drops? 85 drops. Am I right?
Yes.
So what's now the mass of one drop?
85 grams.
What's the answer?
85 grams.
No. 1 gram is 85 drops. What is the mass of one drop?
1 divided by the 85 drops.
Yeah. So our x is what? 1 over 85. What do you get? This is the mass of one drop of water. We are trying to calculate the number of molecules in a drop of water. We calculate that between 40 cm cube and 41 cm cube water, there were 85 drops. That means 1 cm cube equals to 85 drops. We now know that density is mass over volume, and density of water is what? 1 gram per cm. They will give you that in exam, 1 gram per cm cube. So 1 cm cube means 1 gram. So 1 gram means 85 drops. So what is the mass of one drop? What do you get?
We get 0.01118
gram per what? Per drop. Is that correct?
Yes.
Can you go and find the mole of this? What is the molar mass of water? Molecular mass of water, what is it?
2 plus 16.
That's 18.
18.
Is that correct? Good. We know that 1 mole of water means 18 grams, and it contains 6.02 10 to the power 23 molecules. Therefore, 0.0118 gram. How many molecules are there? That's the number of molecules in one drop. Do you get?
Yes.
So you can now see that. So calculate it. It's over a billion.
Okay.
If one drop of water contains over a billion molecules, then how tiny is a molecule? It's so tiny that you can only imagine it. Do you understand what I'm trying to tell you? I'm proving a fact that a molecule of a substance is so small that you can only imagine it. Look at hemoglobin, how big it is. One molecule of hemoglobin, can you see how tiny it is?
It's tiny.
It's so small. Do you get? So that's just how it is. Is that okay? What I'm trying to tell you? So that's all
Yes.
about that. Good. Now let's now go for calculation in mole concept. What is mole? You know that. Tell me the formula of mole. You know in GCSE.
Molar mass of
Mass
mass
over.
mass given over molar mass.
What does molar mass means? From what you have said today,
The weighted
molar mass could be atomic mass, or relative atomic mass. Are you there?
yes.
Could be molecular mass, could be formula mass,
Yes.
could be isotopic mass. All of them. So when you say molar mass, you are not being specific. Molar mass could be atomic mass, could be molecular mass, could be formula mass, could be isotopic mass. Do you get the point now?
Yes.
Good. So if I want to find mole for magnesium, it should be mass over atomic mass of magnesium, because magnesium is an atom. If I want to find, look at it now, mole for magnesium, it should be what? Mass over what? Atomic mass. Am I right?
Yes.
What about mole for magnesium oxide? What will it be?
Mass
Mass
over
over formula mass.
formula mass.
Because formula mass is for a unit compound. Am I right?
Mm-hmm.
What about mole for carbon dioxide? Mass
Mass
over
of
what?
molecular mass.
I like that. Molecular mass. I like that. You are getting it faster. What about mole for sulfur 32? Mass over what? Isotopic mass. Do you get this?
Yes.
I'm just saying atomic mass, formula mass, molecular mass. All of them is molar mass. Is that okay?
Mm-hmm.
Are you getting this?
Yes.
What's the meaning of molar mass in real sense? Mass of 1 mole. Molar mass means what? Mass of 1 mole. So mole, number 1, mole equals to mass over molar mass. This is for masses. Which state of matter has mass? All of them, whether solid or liquid or gas. So whether it is for solid, liquid, or gas, anything that has a mass, you can use this formula for. That's number 1. What's the second one? What's mole? Tell me the formula of mole that you know again.
The formula.
You know it in Jesus. I'll remind you. Mole equals to volume of gas over 24 dm cube. Is that correct?
Mm-hmm.
The volume here, what should be the unit of volume here? Should be in
Liter.
dm cube also. Because dm cube. Do you get?
Yes.
Or it could be volume of gas in cm cube, or equals to volume of gas in cm cube over what?
2,400.
No, volume of gas, if it's in dm cube, divided by 24. What if it's in cm cube? Divided by what? 24,000.
24,000 cubic centimeters.
Do you know what that means?
Yes.
Because this and they mean the same thing.
Mm-hmm.
If it's in dm cube, divided by 1,000, divided by 24. What if it's in cm cube, divided by 24,000? Do you get?
Yes.
If it is in one meet you, you don't play nǹkan. One don't play nǹkan. Lower volume or lower piece now. Mo ti fi piece ẹlẹ fún ẹ. So mole equals to mass over molar mass for masses. Mole equals to volume of gas in dm cube over 24 dm cube, or volume of gas in cm cube over 24,000 cm cube. Do you understand what that means?
Mm-hmm.
Thank you. Number 3. What about this is for gases? This one is for gases. The first one is for masses. This one is for what? For gases. What about for solution? How do you find mole in a solution? Mole equals to what?
Concentration times the mass.
No. You only got it. You almost got it. Concentration times volume over 1,000.
Okay.
The volume will be in cm cube
Mm-hmm.
over 1,000. The meaning is if the volume is in dm cube, do not divide by 1,000 again. Do you get the point?
Yes.
If the volume is in cm cube, divide by 1,000. If the volume is in dm cube, don't divide again, just multiply it by the concentration rate. Do you get the point now? This
Yes.
one is for solutions. For solutions. Is that okay? 3 things. Mole equals to mass over molar mass for masses. Mole equals to volume of gas in dm cube over 24, or volume of gas in cm cube over 24,000 cm cube. Then finally, mole equals to what? Concentration times volume over 1,000 for solution. If the volume is in cm cube, divide by 1,000. If it's in dm cube already, do not bother to divide. Is that okay?
Yes.
Is that okay?
Yes, it's okay.
We are done with this part. So we are done with this part. Done with this part. Now, formula now, before I go to calculation. After this now, we stop. We just go to calculation. We are not doing any. After this part, the remaining one is calculation. I'm not doing anything before. Just go and solve question. Now let's go. Can you start reading? 3-1 formula.
I should start with which one?
Start reading from here. Formula here. 3-1.
Write formulas of ionic compounds from ionic charges and oxidation numbers shown by a Roman numeral,
Thank you.
including
Formula of ionic compound. Formula of ionic compound. You know some of them in IGCS. I want to be sure you just know it. I'll just run over them before we go to calculation. Periodic table. Group. Ionic charge. Valency. Group 1, group 2, group 3, group 4. No, it's too congested. Let me space it out. Group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8. What charge they carry? Group 1 always lose 1 electron, become +1. Group 2 will lose 2, become +2. Group 3 +3. Group 4 is either +4 or -4. What about group 5? Minus, you gain 3, -3. Group 6, -2, we gain 2. Group 7, -1. Group 8 will not gain, will not lose. Valency is now absolute value of the ionic charge. Valency is the absolute value. You don't put the charges on this. Is that okay? So let's go.
Yes.
Which element are we talking about here? Hydrogen, lithium, sodium, potassium. This one is beryllium, magnesium, calcium, boron, aluminium, carbon, silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, bromine, iodine, then helium, neon, argon, krypton, xenon, etc., etc. So from here, you can form any ionic compound you want to form. Am I right?
Yes.
You know a little of this in GCSE, am I right?
Yes, I do.
So what is the formula of lithium oxide?
Lithium oxide.
Lithium oxide. What's the formula?
Li2O. Lithium
That's
2 and
that's
oxygen.
matter. Yeah, let's go. Aluminium fluoride.
Aluminium. Where's aluminium?
Okay, aluminium fluoride.
Okay. So it would be AlF3.
That's smart of you. I'll go for that again. And what about aluminum nitride?
Nitrite.
Nitrogen, aluminum nitride.
Okay. AlN.
That's good of you. That means you can do all of this. So I don't want to waste time on it. You know it, I will skip it.
Okay.
So what you need to do for me is this now. It now says you write an equation to show the formation of aluminum fluoride. Yeah, convert this to word equation, convert this to chemical equation. Aluminium plus fluorine to give, can you convert this to equation? Yeah, tell me what to write. Convert this
So,
to equation.
okay. Al,
Mhm.
that's a solid. Plus F. And is to give Al F3.
The equation is wrong. What is wrong with the equation?
You didn't put the aqueous, solid, or liquid, the
No,
symbol.
leave the same symbol. No, leave not say symbol. It's wrong. Leave say symbol, not say symbol.
Or we're
Fluorine
supposed
does
to
not
put the
exist
charges.
as F. It's F2. F
Oh,
does not exist.
but,
So it's F2. So elements like this, I wrote it for you here. Come and see. I wrote for you. Come on, let me show you.
okay.
If you didn't take notice of it, I'll show you now. Look at it. Oh, no. Molecule. Look at it. F2,
F2.
I2, Br2. We call them diatomic element. They don't exist as one. Each fluorine atom has 7 electrons in the outer shell. It is not stable. Two of them will now come together and form covalent compound. This is fluorine. Look at fluorine. FF. 1, 2. This guy has 6 left. They both contribute to 1, 1. This is fluorine molecule. So F does not exist in this life. It should never exist in the life to come. It does not exist. What normally exists? F2. Is that okay?
Mm-hmm.
Tamuda, do you understand that?
Yes, I do.
So now, therefore, if you want to write, if you are writing equation, bear this in mind. These guys are always written as diatomic molecule. H2, N2, O2, F2, Cl2, Br2, I2. They are always in two. You can't separate them. So
Okay.
hydrogen gas is not H, it's H2. The oxygen that you breathe in is not O, it's O2.
Mm-hmm.
Nitrogen in the air is not N, it's N2. Chlorine gas is not Cl, it is Cl2. Are you getting this?
Yes.
No mistakes again, no mistake again. Now let's, yeah, can you balance it now? I've corrected, can you balance it now?
Okay. We can put a 3 in front of F and then a 2 in front of AL and the other
Is that
A.
correct?
Yes.
Good. So can you, let's do for, can you write for me? Aluminium plus oxygen.
Aluminium.
To give aluminum oxide. From this table, what's the formula of aluminum oxide? Aluminum oxide.
Al2O3.
That's correct. So now write an equation for me to show the formation of aluminum oxide. Yeah, let's go.
Al plus O2
Now you are talking. Now you are talking. To
to
give
give
what?
Al2O3.
Now you are talking. You cannot balance it.
2 in front of Al. Oh, then 4.
Is that correct?
Yes.
So you don't have issue with this. I'm set. Thank God you know you understand this one faster. You know most of them before.
Yes.
Well, but they said now look at what they said here. They said oxidation number. Let me explain that to you. There are some elements they have more than no. Look at it now. Come back here. Sodium is always plus 1. Do you agree? In all its compound. Look at it.
Yes.
Sodium is plus 1. But some elements can have more than one oxidation state. So let's go around with them. Let's do copper 1. So I'm going to do for you copper 1 oxide, copper 2 oxide. So tell me their formula. Iron 2 chloride, iron 3 chloride. So you are getting the formula. Yeah, let's do. This one is copper 2, copper 1. This is copper 2. Am I right? This is iron 2. This is iron 3. Oxide is 2 minus. Oxide is 2 minus. Chloride is minus 1, group 7. So you are telling me that formula. Yeah. What's the formula of copper 2 or copper what? Copper 1 oxide, the first one. What's the formula?
CuO2.
Now you are talking. Copper 2 oxide.
CuO.
Now iron 2 chloride.
FeCl2.
Now you are talking. Iron 3 chloride.
That's FeCl3.
No, thank you. So you know, so you can sort out this one. So we tell you now. What about lead 2 oxide and lead 4 oxide? Lead 2 oxide, lead 4 oxide. Yeah, go on. Lead 2, lead 4. Oxide is this. Oxide is this. Yeah, go on. Lead 2 oxide.
PbO.
Lead 4 oxide.
Pb2O.
Pb.
Okay, Pb2, Pb4, and then we divide each by 2, so it's PbO2.
Now you're talking. Now, smart girl. You're smart. You're a smart girl. That's good. This is very fine. This is very fantastic. I'm done with this one. So I'm done with this. I said, using ionic charges, we've done that. In our solution number, we've also done that. Reaching the Roman mineral. Is that okay?
Yes.
Now say prediction of the ionic charge. So you know the ionic charge of an element now, right? Group 1 is always plus 1, plus 2, plus 3, plus 4, minus 4. Group 5 is minus 3. Group 6 is minus 2. Group 7 is minus 1. Group 8 is 0. Is that correct?
Yes.
So we are done with this. Next one, B. Can you read?
Recall of the names and formulas for the following ions.
Yeah, can you start naming them?
Sorry?
What is that? What is that? What's the name of NO3 minus? The name.
Nitrate.
Go on. Go on.
Nitrate. Carbonate.
Go on.
Carbonate.
Go on.
Sulfide.
Sulfate. Okay, I got
Sulfate.
it now. Let's just stop there. Now, this guy, this one are ide. This one is ide. This one is 8. Are you there? Let's go. This is nitride. Phosphide. Are you there?
Yes.
Chloride. Are you there? Which other one
Yes.
is there? I'm going. Sulfide. It's okay, let's stop there now. This is carbide.
Carbide.
Carbide. Is that we lose for game for that? Now, what's now nitrite? NO2 minus. Nitrate is NO3 minus. Phosphite is PO3 3 minus. PO4 3 minus. Chloride ClO2 minus. chlorate ClO3 minus, sulfite SO3 2 minus, SO4 2 minus, carbonate, there's no carbonate, CO3. So this one doesn't exist. Doesn't make sense. Look at it. Doesn't follow a pattern. If it's a single element, end with ide, chloride, nitride, sulfite, sulfate, no, all those ide that they are single elements. Do you get the point?
Yes.
Bromide, iodide. But when it comes to those guys that contain oxygen, some are 8, some are 8. The one that contain more oxygen is 8.
8.
The one that contain less oxygen is 8. So nitrite is NO2 minus. What about nitrate? NO3 minus. What about phosphite? PO3 3 minus. Phosphate, PO4 3 minus. Can you see now? The 8 contain one more oxygen than the 8. Do you understand?
Mm-hmm.
The 8 contain one more oxygen than the what? Than the 8. Hold on. SO4 2 minus, CO3 2 minus. Is that okay? Does it make any sense? Good. Let me see. I'm not addressed. We don't this. We don't this of it. Hydroxide. Okay. Now there's all those one. This guy now. Let's see more. We have hydroxide, cyanide. Are you there?
Mm-hmm.
Good. Etc. But now when it comes to this kind of thing, look at this. If this is carbonate, what is the charge of H? H is plus. Am I right? If you add this guy to H, what will it give you now? Give you what? H. How many minus will it carry now?
1.
Minus 2 plus 1. What's the overall charge?
Minus 1.
Minus 1. I'm sure you understand. I got that.
Mm-hmm.
What about this? What will it give you?
4 minus.
Is that okay?
Yes.
So this is carbonate, hydrogen carbonate. Sulfate, hydrogen sulfate. Is that okay?
Yes.
It's carbonate. This is hydrogen carbonate. Okay, hydrogen, this carbonate, hydrogen carbonate. Hydrogen carbonate. This is sulfate. Hydrogen sulfate. Is that okay?
Yes.
So what about the phosphate? What will this guy? So what will be the charge of this guy? What will be the charge of this guy? What will be the charge?
Minus.
Minus what? 2. Then minus 1. Do you agree?
Mm-hmm.
What do you call this guy? Phosphate. What do you call this guy? Hydrogen phosphate. Is that correct?
Yes.
What do you call the last guy? Dihydrogen phosphate. 2 hydrogen, dihydrogen phosphate. Does it make sense to you?
Yes, it
Phosphate.
does.
You add 1 hydrogen, becomes what? Hydrogen phosphate. Add the second hydrogen, now become what? Dihydrogen phosphate. So what do you call the name of this guy? Yeah, let's go. Yeah, we call disodium hydrogen phosphate. Are you there?
Yes.
What about this? Sodium dihydrogen phosphate. Am I right?
Mm-hmm.
Dihydrogen. Is that okay?
Yes.
Disodium hydrogen phosphate. Sodium dihydrogen phosphate. Is that okay?
Mm-hmm.
Does it make any sense? Then now, generally, you can get it from the acid. So how do you know? What do you call the name of the acid? This is phosphoric acid. So it's a weak acid. You lose 3 proton. So 3 plus, so 3 minus. Do you agree that how you get the charge? This guy is a strong acid, 2H plus, so 2 minus. Is that okay?
Yes.
HNO3 is a strong acid, H plus, NO3 minus. Is that okay? So of course HCl, H plus, Cl minus. Yeah, give me the name of these guys. The first acid what? Phosphoric. You call it, some guy call it phosphoric 5 acid. Phosphoric 5 acid. Sulfuric acid.
Nitric acid.
Nitric acid. Of course. Hydrochloric acid. What about the ion? This is now phosphate ion. Phosphate ion. Sulfate ion. Nitrate ion. Of course, chloride ion. Chloride ion. Do you get the point now? So if you have all this, you can now form the compound from them. So let's go. So let's play around with it. Sodium, magnesium, aluminium. So you can talk about hydroxide, cyanide, carbonate, sulfate, nitrate, phosphate, hydrogen carbonate, hydrogen phosphate, dihydrogen phosphate, hydrogen sulfate. You can form compound between them and all of this. You agree? And of course, there is ammonium. Ammonium is always +1. Copper can be copper 1, can be copper 2. Silver is always +1. Zinc is always +2. It's like those silver and zinc, they seem to be transition metal, but they don't form very oxygen state. No, let me remove them from myself. Let me look at the one they said you know in syllabus. Yeah, that's it. Silver, yeah, they said you know those two. Yeah. So is that okay?
Yes.
So you can form. So if I also form any of the compound between any of the, you can form any of them. Am I right?
I'll
Silver,
have to
zinc.
practice some more.
What did you say?
I said I'll have to go over them and practice till I know all of them.
Do you get that? Exactly. Now you don't have to memorize it. By the time you are solving more questions. You'll be coming across them as you're solving questions. Oh, this guy, this guy, this guy. You see it again. Now we're going to talk about this guy under inorganic chemistry again as a topic.
Okay.
Is that okay? Some topic in chemistry they are repeated. Is that okay?
Yes.
But we are not going to talk about how to form them between comma and comma. Just remember all of this. Is that okay? So what's the formula of What's the formula of sodium hydroxide?
NaOH.
Aluminum hydroxide.
ALOH.
Aluminum hydroxide.
ALOH3.
What is AOH before? Now, silver sulfate.
Ag2SO4.
That's correct. Zinc hydroxide.
ZNOH2.
Copper 2 sulfate.
Copper 2.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Gel Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the SACE team. at agiletech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, and also for the EdXL. So we have for the Cambridge E levels and EdXL E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time, even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you. And the good news about this is, what I've discussed with the sales team is, we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Agile Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So again, what are you waiting for? Just send an email to the sales team. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2025, watching this in 2026, watching this in 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to miss out.
Copper 2 sulfate.
CuSO4.
So you can use it, so that's how to know all of them. You will know them by practice. You don't have to memorize them.
Okay.
You can't come that you practice them, that you know all of them often. Do you get it? Just like the way you get now. Do you understand that? You will know all of them one by one. Don't worry. You don't need to worry about. Is that okay? So
Yes.
we are done with this part of it. Is that okay?
Yes.
Next one, you know how to write equation.
Right,
Now,
and
how to balance equation, how to write equation, you can do that yourself. That's not a problem. Then use appropriate state symbol. Is that okay? Solid, liquid, and gas and aqueous. Let me do an example on that for you. Calcium carbonate. Calcium carbonate is not soluble. It's not soluble. It's an insoluble solid. So it's a solid. It can react with hydrochloric acid, which is hydrochloric acid is always in solution. Am I right? So it's aqueous. What are the products? GCSE. A carbonate plus an acid gives you the product.
calcium chloride.
Which is soluble, so aqueous. Water, which is liquid. And carbon dioxide, which is a gas. Is that okay? Can you see now?
Yes.
So we have solid. This guy is solid. This guy is aqueous. This guy is aqueous. This guy is liquid. This guy is gas. Can you see now? All of them are represented here. A solid calcium chloride, calcium carbonate dissolved in dilute hydrochloric acid to give a soluble calcium chloride plus liquid water plus gaseous carbon dioxide. Is that okay? So not balancing.
Yes.
So this one, equation will not be voila for you. You'll be learning to learn equation later. That will not be a problem. Is that okay? You can learn to do that. Good. That's no problem. I don't want to waste time on that. Next one.
Define
Define
and
the
use.
empirical molecular formula. Understand anhydrous and hydrated. So empirical formula and molecular formula. Empirical molecular formula. What's empirical formula? How do you define that? Empirical formula. Hello? Hello?
Yes, sir. It's a chemical compound in its simplest ratio.
Hey, you tried. You try. You always say something. I like that. You don't agree, you don't know anything. You don't agree, you don't know something. You always say something, even if it's not correct, you try. That's a very
Yes.
good spirit. It's a very good spirit. Just try to say something. Because if you don't say it, you don't have an idea of saying it your own. No, say it anyhow. Even if it's wrong, say it. So
Okay.
let's do something. Compound, molecular formula, empirical formula. Benzene, hydrazine, ethane, ethene, glyceraldehyde, hydrogen peroxide, glucose, ammonia, ethylene glycol, dinitrogen tetroxide, dinitrogen tetroxide, dinitrogen tetroxide, ethanoic acid, let's stop there. Yeah, let's go. Benzene is actually this molecular formula. Benzene is actually C6H6. This guy is N2H4. This guy is C2H2. This guy C2H4. This guy C3H6O3. This guy H2O2. This guy C6H12O6. Nobody will ask all of these, so don't worry. Just we'll learn to know some of them later in organic chemistry. Ammonia is NH3. I think I call it C2H6O2. This guy is N2HO4. This guy is C2H4O2. So can you now assume a molecular formula? Now let's now go for the empirical formula. It is simplest whole number ratio. Simplest whole what? Simplest whole number ratio. The simplest whole number ratio. Now look at the molecular formula of hemoglobin. How do you find the empirical formula? Yeah, let's go back to hemoglobin. How do you find the empirical formula of hemoglobin? 4 can divide everybody. You can divide 2 by 4. Do you agree?
Yes.
4 you divide everything by, so it should not be F
Mm.
S2. Divide everything by 4. 4 will divide everything through. Do you agree? Get the value for self. Do you get that? This one we wrote here is molecular formula. We now divide 2 by 4, it now give you what? Empirical formula. Is that correct?
Yes.
Now let's go. So tell me, you tell me what will be the empirical formula here? You tell me.
CH.
CH. Thank you. Go on.
NH2.
Go on.
CH.
Go on.
CH2.
Uh-huh.
CH2O.
Go on.
HO.
Mm-hmm.
CH2O.
Go on.
NH3.
Go on.
CH3O2.
CH3.
NO.
CH3O. Is that correct?
Yes.
Go on.
NO2.
Mm-hmm.
CH2O2.
Is that okay? So you just
Yes.
know how to divide 3. That is the simplest whole number ratio of the component atoms in one molecule. What about molecular formula? Okay, let's write that now.
Okay.
No. Molecular formula shows the actual number of all the different atoms in one molecule of an element. Is that okay?
Yes.
What about empirical formula? Empirical formula shows the simplest, shows the what? The
Simplest one.
simplest whole number ratio of the component atoms in one molecule, of the component atoms in one molecule. Component atoms in one molecule. Is that okay?
Yes.
Good. Now that's settled. Now we're gonna go for calculation involving it. Is that okay? You have to find how to do that now.
Yes.
You know how to calculate and break up from life. You are given they told them if they told you now examples. What time is it now? What time is it, please?
It's 12:39 for me. 11:39 for you.
That's time for me. That's good. That's good. Now, so we still have enough time, so we can finish it and solve one question. Suppose you are given that maybe. I have to do quickly a rough calculation. Where did I drop my phone? Sorry, I'm looking at my phone. I want to quickly do a calculation before I can give you.
Okay.
Please, 1 minute. 1 minute. Okay. It's behind my laptop. Sorry. I want to do it. I've seen it.
All right.
Now, so suppose you are given. Okay. 1 minute, please. Please, 1 minute. 4, 6. 1 minute, please. C4. C4H6. Then C4H6. Then CHH12. Yeah, CHH12. I want to do the calculation, please. 1 minute. CHH12, CHH12, C8. That's 96H12. 96 C8, C12 times 8. Then plus 12. CH 108. 108. 12. No. 96 divided by 108 times 100. So an organic compound,
Okay.
hydrocarbon. You know what hydrocarbon mean? Contain carbon and hydrogen on the right.
Mm-hmm.
The composition is 88.88%. Now say, and the relative molecular mass is 108. Do you get the question? Is there what does hydrocarbon mean? A compound containing carbon and hydrogen only. Do you get the point?
Yes.
Hydrocarbon contain hydrogen and carbon only. Is that okay? The carbon is 88.89, not 88. 88.89%. You now say MR is 1. You now say find one. Find empirical formula. Number 2. Find molecular formula. Can we do this together?
Okay.
Let's start. What do you do? They said the compound is hydrocarbon, meaning containing hydrogen and carbon, no other element is present, right? So can we do like this? Carbon and hydrogen.
So we take that as our mass given,
Yes.
88.89,
What will hydrogen
divided,
be? What will hydrogen
hydrogen will be 100 minus 88.89.
that'll be what?
That's 11.11.
1. So divide by what?
Yes,
By 12.
12.
Divide by what? By 1. What do you get?
7
11.1.
point 7.4075.
0. Then divide by the smallest, right?
Yes,
Is that how you do it? Is that how you normally do it?
yes, you
After
divide by
finding the mole, then divide by this, find the mole ratio, right?
yes.
7.40. 7.40. What do you get? 1. What do you get there?
1.499.
1.499. What we now do here now? What's the Becca
After
formula?
are we allowed to round off the hydrogen to 1?
To 1, 1.49 to 1. Did you say that? Yeah, be careful. Hey, I will take that from you. How can you add 1.49
2.
to 1? Hey, is that what?
1.
That
So on
cannot
the
be done
calculator,
again.
it's 1.4998. So we can round it off to 1.5.
Okay, I agree. Now you are talking. And now say you round it up to 2. Be careful, I beg you. Now what do you do now? What's
So
now the
now
breaker formula?
we can write
What is the
CH2.
empirical formula? Is the whole number ratio, whole number, not fractional, not decimal. Multiply by 2. Do you get? Give you a C to H what? H3. Do you get?
Mm-hmm.
Look for a number to multiply both sides to give you a whole number. Don't round it up. If it is 1.99991, that is 2. Or 3.002, that is 3. Do you get the point? But you can't round up
Yes.
1.9, 1.5 to 2. It's not correct. So what do we now do? C2H3 into N. We don't know what N is. Come back here. For benzene, what is N for benzene? What you need to divide through is what's called N. For benzene,
Mm-hmm.
N is 6.
Mm-hmm.
N is 6 here. Here is 2. Here is 2. Here is 2. Here is 3. Here is 2. Here is 6. Are you getting? You know what N means now? N means the number you
Yes.
need to divide through. 2, 2, 2, 2, 2. Is that correct?
Yes.
We don't know what N is. We put N equals to what? What's molecular mass? 108. Yeah, let's go. What's the answer now? Carbon is 12. 12 times 2, 24. Hydrogen is 1. 1 times 3, 3. Into N equals 108. 27N equals to 108. N equals to what? 108 over 27. What's the
4.
answer? That should be 4. Therefore, what's now the molecular formula now?
C8.
C2H3 into what? Into 4. What's the answer?
C8. H4.
C8H2. Calculate that now. So do not round up 1.5 to 2. It is not correct. In fact,
Okay.
there was a year we did it like this. Look at it. After dividing by the smallest, after dividing by the smallest, this one is I saw one of them like this in GCSE. Carbon, hydrogen, nitrogen, oxygen. This guy was 2.4. No. This guy was 1.2, 1, 2.4, 2. What did you do? Oh, no, there is one that should be 1. Hold on. Give me a minute. Chlorine is 1. No, I want to write oxygen as 1. Sorry. Oxygen was 1. Others, they didn't give 1. Oxygen was this one. Divided by this one. To get this. What do you do? Make them whole number. You can't add 1.2. If you give exact 1.2, you can't add it up to 1. No. There'll be something to be done about it. You can't leave it to 1. It's not correct. What do you multiply everything to give you a number? Can't use 5. What would this be? 10.
12.
Thank you. Go on.
6.
6.
5.
Can I give you a whole number perfectly well? C10, H12, N6, 05. That's the formula. It should be whole number ratio. Agree on that one? After dividing by the smallest, I have many in my head. Iron, it was iron and oxygen. Well, let me even do this. I don't like this. Let me do the real calculation for you for this one. Can you do this for me?
Okay.
55 point, calculator, please. Calculator. 55.8 times 3 plus 64. What do you get?
Sorry?
55.8 times 3, then plus 64. 55.8 times 3. Then your answer plus 64. What do you get?
231.4.
231.4. An oxide of iron, of mass 2.314 was reduced in a stream of hydrogen gas under heating to leave a residue of, again, 55.8 times 3. What do you get?
55.8
times 3.
167.4.
Residue of
160.
1.5. 167 or 57?
167.4.
Thank you. 1.674 gram. Deduce the empirical formula. Yeah, let's do this together.
Okay.
Let me do a diagram of this. Let me tell you what this means. Look up, please. It means no. Yeah, I can do like that. A combustion tube. Are you listening to me?
Yes.
Then this. Hydrogen gas is going in here. Heat is being applied here. This is now an oxide of iron. Is that okay? And is that okay? You are eating it. The reaction occurring is what? FeX. I don't know the formula of the iron oxide. I will call it FeXOY. Is that okay? I don't know what the formula. Plus hydrogen. Hydrogen takes O from that guy to give you what? XFe plus what? YH2O. Is it balanced? Check it out. Is it balanced? I don't know what X and Y is.
Okay.
There's an oxide of iron. When you add hydrogen to it and you heat it, the hydrogen takes away all the oxygen from him and make him iron. What is the mass of the iron oxide? 2.314 grams. Am I right? What is the what's that residue? What is my residue? The solid left behind. Is that okay? Can we get a bigger formula from here? Again, iron. Iron is what? 1.674, right?
Yes.
What will be the mass of oxygen now? Mass of iron oxide, 2.314. Mass of iron alone, 1.674.
So it's 0.64.
Thank you. So just remove this from the 0.640. Take both of them to 3 decimal places.
Okay.
Don't write 640. Is that okay?
Yes.
What do you do now? Divide by the atomic mass. So yeah, go on. 5.8. This one is 16. What do you get?
0.03 for iron.
0.03. It will be 0.04.
Yes.
So what do you do now? Divide by the smallest, right?
Yes.
0.03, that will give you 1. What will this one give?
1.333.
What will we do now? You
We
can't
will-
round it up to 1, it's wrong.
Sorry?
You cannot round up 1.333 to 1, it's wrong, it's not correct. What do
Okay.
you multiply both sides with to give you all numbers?
Mhm.
What does 1.33333, what does it mean? One whole number, 1 over 3. Do you agree?
Yes.
So what do you multiply 1 over 3 with to give you a whole number? 3.
Oh.
1.3333 recurrent decimal means one whole number, 1 over 3. Now, the answer you got now, can you multiply by 3? What do you get? Do 0.3, 0.04 over 0.03. Sorry. Do 0.04 over 0.03. What do you get?
One and as a fraction, 1.333
Multiply by 3. What do
times
you get?
3, 4.
Exactly. It will be 4 because
Okay.
the 3 is recurrent. It's a recurrent decimal. 3 continues indefinitely. That means
Mhm.
actually one whole number, 1 over 3. Then multiply by 3, it give you exactly 4. It give you, take this to improper fraction. 4 times 3 times, that's 4
5
over
over
3
2.
times 3. Give you exactly 4. Exactly.
Okay.
Do you get that?
Yes, I do.
And if it doesn't, 3.99999 is 4. Do you agree?
Mm-hmm.
So do you agree? Even if it doesn't, 3.99999 is 4. So this will be 3 now. This will be what? 4. What's the formula of the compound now? Fe3. Tamuda, do you understand it?
Yes, I do,
You
sir.
can know this chemistry that you are so sure before exam that you are going to get an A-star. You are so sure that there is no doubt in your mind that this, I will get it. Because
Mm-hmm.
I'll give all the type of things they can ever ask you. Then if you now sit down and
Okay.
practice on your own and you bring back to me the one you don't understand, you're on top of the game. There's nothing to be afraid of. Is that okay? So I'm
Yes.
giving you different way that they can answer the question so that you can understand it. Have you this understood?
Yes, sir.
Now, if you are given an organic compound and they told you that they said organic compound, they said carbon is 64%, hydrogen is 8%. Find the empirical formula. What will you do? They say it's an organic compound. You have to assume that the last element is oxygen. They
Yes.
didn't tell you because this to add is 72%, it's not up to 100%. Am I right?
Yes.
After carbon and hydrogen, the commonest atom in organic compound is oxygen. Do you get? So
Yes.
if you are not told that the third element is oxygen, you have to assume it.
Mm-hmm.
Because it is the commonest element after carbon and hydrogen. Do you get? So you have to
Yeah.
assume that this implies O will be 100 minus 64 plus 8.
That's
O
28.
8%. You have to assume that. Settled.
Yes.
So good. I think this is fine for this level. Let's go to the latter part. So now this one now.
Nice.
It should have saved my time. You can just show you. Anyway, no wonder. Let's go. So when we talk about, look at it, when you have MgSO4 7H2O, CuSO4 5H2O, BaCl2 2H2O, Na2CO3, NH2O, then FeSO4 7H2O. These guys are called hydrated salt. Is that okay?
Yes.
They are obtained by crystallization. So if you react magnesium oxide, excess of this guy with sulfuric acid, you get magnesium sulfate and water. This will be aqueous, this will be liquid, this will be solid. Two ways of getting this guy out. If you do evaporation to dryness, you heat it until all the water goes off. Are you there? If you do evaporation to dryness, you evaporate the solution until all the water goes off. Evaporation to what? To dryness. Do you know what that means? You take the solution, you heat it until
Mm-hmm.
water goes away. Is that okay?
Yes.
Are you there? You will get magnesium sulfate solid. This is called anhydrous. It should not have any water or crystallization. But if you heat, number one, you of course you first filter. What do we do first for? You first filter off the excess unreacted MgO. Do you understand what that means? You added excess MgO such that all the sulfuric acid reacted. Is that okay?
Yes.
When the reaction has finished, is that okay? You
Mm-hmm.
filter off the MgO that do not react. Is that okay?
Mm-hmm.
After doing that, you can now do evaporation to dryness. You heat that solution until all the water goes off. You have MgSO4 behind. Is that okay? Or you can heat until a saturated solution is what? Is obtained. Then number two, cool the solution. Cool the solution to form crystals. To form what? Crystals. Number three, filter of the crystals. Filter of the crystals. Then this time you get this. It's still solid though, you get it.
Okay.
So this is called hydrated salt. If you heat it until all the water disappears, you get MgSO4, no water attached. If
Mm-hmm.
you heat it to the point of crystallization and you then cool the solution obtained, crystals will be formed. You filter out the crystals and you dry between two strips of filter papers. You get this guy. This guy is called hydrated salt. The other guy is called, this water is called water of crystallization. That's where we are going. The water attached to the salt, when the crystals of the salt was produced, is called what? Water of what? Water of crystallization. Do you understand this?
Mm-hmm.
So how do you get an hydrous salt from solution? Heat the solution until all the water disappears. Am I right?
Yes.
How do you get hydrated salt? You heat the solution until it forms a saturated solution. Are you there?
Yes.
Then cool the saturated solution so that it can form crystals.
Mm-hmm.
After cooling, then filter off the crystals. The crystal obtained will be a hydrated salt.
Okay.
But if you heat it till the point of dryness, what we get is an hydrous salt. Does it make any sense?
Yes.
So question now is this: how do we calculate the value of x in this example, something like this? How do you get the value of x? Two ways of going about it. Two ways of going about. Look at it. I have empty crucible with lid on it. Empty crucible with lid. Then crucible plus dehydrated salt. Then crucible plus hydrated salt after heating. Then crucible plus hydrated salt after heating. Then crucible plus hydrated salt after heating. Crucible alone, 80.00 gram. You know what the crucible is? Like a
Yes.
dish we used to eat something in the lab. Is that okay?
Yes.
80.00 gram. So you now put the solids into it. Can you do this can you do a calculation for me, please? Calculator, please. Are you there?
Yes.
24.3
Mm-hmm.
plus 32.1
Yes.
plus 64.
Mm-hmm.
Are you there?
Yes.
Then plus, I'm coming to 18 plus 18 times 7. Put 18 times 7
Plus
bracket, plus 18 times 7. What do you get?
210.4.
Let me show what you did. What you did was 24.3 plus 32.1
Mm-hmm.
plus 64,
Yes.
then plus
18 times 5
plus
in bracket.
126.
Mm-hmm.
What do you get?
Plus 126. 246.4.
Good, that's correct now. 246.4. Then, hold on, then, excuse minus 126. 120.4. I want to do a calculation, don't worry. I want to get the perfect value. That I'm doing that.
Okay.
Then there is 1.204 times 2 times 2. 1.204 times 2. 2.408. 2.464 times 2. 4.928. Okay, that's okay. Yeah.
Mm-hmm.
So let's go. Let me take it to 3 decimal places. Then here, before 18 was what? 84.928. Then this one now 82.408. 82.408. 82.9. 83 point no 82 point what 82.602. Now, when do I stop eating this guy? How do I know I should stop eating? From my data, look at my data. Water is going off. When do you know when to stop eating?
When the mass is now the same.
Thank you. When
It's
the mass
not.
makes, that means there's no more water to go.
Yes.
So now, so from here, what is the mass of this one? Is what? Empty crucible, am I right?
Yes.
Empty crucible plus what? Plus lead. What about this? Crucible plus hydrated salt, am I right?
Mm-hmm.
Plus lead. What about this? Crucible plus residue plus lead, am I right?
Yes.
Crucible plus residue plus lead. Crucible or residue plus it. Is that okay?
Yes.
What's the name of the last residue? That is an hydrous salt, am I right? We
Yes, it
believe that
is.
that last guy has lost all his water. So from here, can we get the mass of X? We want to get, they said it's magnesium sulfate. They said the guy is magnesium sulfate dot X H2O. We have to find the value of X. Are you there?
Mm-hmm.
So how do we go about it? Yeah, let's go. So can we write like this, that mass of magnesium sulfate hydrated. What is the mass? It will be what? 84.9. Is that 18 or 28? And I've cleaned it to 84 point. Is that 918? Oh God. What do you call the mass? 246 point. Can you do it for me?
Okay.
246.6. 246.6 divided by 100. What do you get?
You said two what?
246.6
246.6 divided by
divided by
100.
100. They
2
multiply
point
by 2. Multiply by 2.
4.932.
932.
Mm.
So it should be 28. It should be 28. Thank you. It's okay
Okay.
now. Thank you. Yeah, let's go.
All right.
928 minus what? 880. So 4.928. That's mass of anhydrous salt. Am I right? Of hydrated
Yes.
salt. What's mass of this guy without water? How do you get that from this table?
We say
What minus what?
80, 84.928.
No. 82.408. In
Oh,
the last
minus.
guy, there's no water in the last guy. It's purely so minus 80.000. Do you agree?
Yes.
This guy is the other one is just crucible and the anhydrous salt. And the anhydrous salt is MgSO4. Do you agree?
Mm-hmm.
You're not sure.
I agree.
Do thank you. And do you understand?
Yes.
Good. Now, what do you get here is what? 2.408.
2.408.
What's now the mass of water? You either say 4.928 minus 2.408. What do you get?
Minus 2.408. 2.52.
2.52 gram. Or how can you do it? Come back here. From
Mm-hmm.
this, how can you do it? From this graph? How can from this diagram? How can you get it?
How can we get what? The
This,
mass of water?
yeah, this guy contain crucible, the salt, and water. What about this guy? Crucible and salt alone.
Yes.
So the difference
So,
between them is the agree is the measure of water.
we
The
can
first
substitute
guy contain the crucible, the salt, and water. The last guy contain crucible and what?
the residue.
And salt alone. There's no water there. That's why the mass is no longer changing. Do you agree?
Yes.
So the difference between the two of them is what? Water. So you can also do like you get the same answer. You can also or you could do it or it is what?
84.
84.928
82.
minus 82.408. You get the same answer.
Yes, we do.
0.52. Do you get? So either of the two can be used for you. Is that okay? You get
Mm-hmm.
the same answer. So let's now go ahead and get the value of x. What is mole of MgSO4? 2.408 over mr. What's the mr of MgSO4? Can you do that? Magnesium is we have to do this. 24.3 magnesium plus 32.1, then plus 64.
120.4.
And what?
120.4.
What do you get? So mole of water. What do you get?
0.02.
0.02.
Mm.
What's the amount of water? 18. What do you get here?
0.14.
What's now the value of x from here? You are saying that the mole of magnesium sulfate is 0.02. Mole of water 0.14. Divided by the smallest. Am I right? To find the mole ratio.
Mm-hmm.
So over 0.02, that'll be 1 over
7.
0.02. That'll be 7. That will compound is what?
8.
MgSO4 dot 7 is 2. Do you get?
Yes.
Find the mole of both of them, then find the mole ratio. So you said you know how to do this.
Mm-hmm.
Is that okay?
Yes.
Good. What if they give you this? I should have leave you. Should have left you, but hold on before you go. What they give you? What if they tell you that? What if they tell you that the same guy, the same data? They said is X SO4 dot 7 is 2O. So you find the AR of S. Find the what? AR of what? Of X. The same data. Again, do not be mass of what? XSO4 dot 7 is 2O. Are you there?
Yes.
The mass of XSO4, the mass of H2O. The same data, but this time they said they don't know what X is. X is a metal.
Mm-hmm.
We want to find the value of, we want to find X. Is that okay? So what's
Yes.
the mass of that of the 4.928? The same data. 4.928 Then without water, 2.408. 2.408. The mass of water alone, 2.52. Yeah, how do you find X? Five to zero, 520. Yeah, you add 0. Consider decimal places. But that's our 3 decimal places, so I should keep it to 3 decimal places. So how do you find X here? We didn't tell it's magnesium, said it's X, but he said the value of X is 7. So what we do here, just say, can you find the mole of magnesium sulfate? I mean, can you find the mole of this guy? No, you can't. Because you don't know what X is.
Mm-hmm.
Which of the mole here can you find?
For what?
You can't find the mole of XS4.7 water. Because you don't know what X, you can't find the molar mass of X. You can't find the mole of this. Because mole is mass by molar mass. You can't find it because you don't know what X is. Which of the 3 of this guy can you find the mole? Whose mole can you find among the 3 of them? This, and this. Whose mole can you find?
The water
Now, mole of what?
of H2O.
Exactly. That's the way you can find. You can't find others. Because they have unknown in them. You can't find them. You just want to find mole of water, mole of H2O. What's the answer? 2.520 over 80. What do you get? 0.14.
Yes.
That's so that will go before, right?
Mm-hmm.
So mole of water is 0.14. So from there, how do you now get it? What is the mole ratio between water and XSO4? XSO4 and water. What's the mole ratio? 1 to 7. I'm like they gave you that. He said water is 7.
Mm-hmm.
Are you there?
I'm there.
Good. And you understand?
Yes, I'm getting it.
So good. So what is the mole of water now from my experience? Water is 0.14 mole. What would not be the mole of this guy? Can you find it? Ratio 1 to 7. When XSO4 is 1, water is 7. So what is now XSO4 if water is 0.14? Can you cross multiply?
Yes. And then
Our
X
X is
will
what?
be
0.14 over 7. Am I right?
0.02.
0.02 mole. That's the mole of X. But do you
Mm-hmm.
know the mass of X? Do you know the mass?
We don't know the mass.
Mass of, just find the mole of this guy now, right?
Yes.
And this is the mass. Do you agree?
Mm-hmm.
We don't know, we can't find the molar mass because we don't know the identity of X. But now we have found that this guy, the mass is this from experiment. That same guy, the mole is also this from calculation. So I have the mass, I have the mole. Can I find the molar mass?
Yes.
Good, now you're talking. From experiment, the mass of XSO4 is 2.408 grams from the data they give us.
8 grams.
The mass of water is 2.520 grams. We now found the mole of water, but we know that from the formula they gave us here, they said it is XSO4.7 water. That is 1 mole of the, listen very well, 1 mole of the hydrated salt contains 1 mole of anhydrous salt and 7 moles of water. Do you get?
Yes.
What this means? Please, you have to, you must recite that in your mind. 1 mole of hydrated salt contains what? 1 mole of anhydrous salt and what? 7 moles
Of what?
of water. They told us that from the formula. We know that. So if I find the mole of water, I will find the mole of the guy. I'll divide by 7. The mole of the guy now. So I'm going to use mole. I'm not going to use mole equals to mass over what? Molar mass. What's my mole? 0.02. What's my mass? 2.408. 2.408. I cannot find the molar mass. My molar mass will be what? 2.408 over 0.02. What do you get?
4.8 divided by 0.02. 120.4.
120.4. That means X SO4 is what? 120.4. I don't know what X is. X so far is 32.1. Octane is 16 times 4 is equal to 120.4. X 64 plus 32.1, 96.1 equals to 120.4. So my X is 120.4 minus 96.1.
24.3.
24.3. That is magnesium.
Mhm.
Is it now? Do you understand it now?
Yes.
So you have to go by it and take time to digest it. Take time.
Mm.
And make sure you understand it your own way. When you see
Mm.
question, you will solve it. I'm telling you. They give you 10 questions, you solve all of them.
Okay.
You solve all of them. This one I just saw for you now came out in practical paper 3. This one just for you came out in paper 3 practical. They
Okay.
ask to weigh, you do everything, and now they do the calculations. Do you get? So I
Mm.
think that is fine. That is fine. You are done with this. So the latter part of it now is now this one doesn't need any teaching. It's just solving question.
Okay.
We can solve. So I already can solve some going for your needs. Then just solving question. Nothing. Not just all you need to do is to use what mole equals to mass over molar mass. Mole equals to concentration times volume over 1,000. Mole equals to volume of gas over 24. That's what you need to do for them. Is that okay? But you
Yes.
need to know what is concentration. What does it mean? What unit of concentration? When you say concentration,
Grams per mole.
it can be mole per dm cube or
Mm.
what? Or gram per dm cube. Is that okay?
Yes.
If I do, yeah, look at what I'm doing now. If I do this, I weigh an empty beaker. 120.00. I added sodium carbonate to it. Now became 130.60. I now added I added about 100 cm cube of distilled water. Then became this. I added the rod and I stir it, everything dissolved. I transfer it to this flask. We call it 250 cm cube volumetric flask. I transfer it here, right?
Mm.
I now rinse the beaker. Also rinse the beaker. Rinse beaker and funnel. Rinse beaker and funnel with more water into it. Everything I'll get here. And now carefully add more water, more distilled water. Is that okay? More distilled water. Everything will become this. When you have added it finally, you may have to use a dropping. You know they call it dropper or dropping pipette. Do you know what a dropper is?
Yes.
A dropping pipette or a dropper.
Yes, I know it.
Like this thing, you know it, Abi?
Yes.
Like the one you used to take your indicator. Do you get now?
Mm.
Or the
Mm.
one they used to do eye drop when you go to hospital. Like it looks like that. You used to fill it up. So this guy now, we now say find the concentration one in mole per dm cube. Number 2 in gram per dm cube. So let's do this together. So what is the mass of sodium carbonate here?
130.6
Is that 10.6?
20. 10.6.
Good. So mass of number one, mass of sodium carbonate is what?
10.6.
10.6 grams.
Mm.
Mole will now be what? 10.6 over mr. Are you there? Which is what? 10.6. Molar mass of that guy is 106. Are you there? So degree
Yes.
was
It will be
0.1 mole.
1.
So what's the unit of concentration in mole per dm? Concentration in mole per dm. What is unit? From the unit, it be mole over volume in dm cube. Do you agree?
Yes.
But it is mole per dm cube. It will be mole over volume in dm cube. Do you agree?
Yes.
What is a mole? 0.1 mole. What is the volume of the solution? This thing is 250 cm cube. So take it to dm cube.
250 cm divided by 1000.
I'll give you 0.25 dm cube. What's the final answer?
0.4.
0.4 mole per dm cube. Can you see now? That will do it now. That's how to do it.
Yes.
Find the mole, find the volume, then do mole over volume. That's all. They now say you go and find in gram per dm cube. In gram per dm cube is not difficult now. You can either say gram per equals to what? Mole per dm cube times what? Times molar mass. Mole per dm cube is what? 0.4. Molar mass is what? 106. What do you get?
42.4.
42.4 gram per dm cube. Now to prove, let me prove it to you. Hold on, just hold on. Remember that mole equals to mass in grams over what? Molar mass. Is that correct?
Yes.
Can you multiply both sides by concentration? It will become what? Mole per dm cube
Is equal
equals to
to
gram per dm cube over molar mass. It's the same thing. I can multiply both sides by mole. Gram. This one, I turn this guy to mole per dm cube. I turn down to what? Gram per, because it's in gram. I turn to gram per dm cube. I didn't do anything special about molar mass. It's the same thing. You can also know this. If mole equals to mass over molar mass, then mole per dm cube will also be equal to what? Gram per dm cube over what? Over molar mass. Is that okay?
yes.
Is that okay? So after to condensation, that's all we need to do now is to solve question. Leave it. I've seen it.
Yeah, it's fine.
I want to leave.
It's
I want to leave.
all right, no problem. Thank you, sir. Thank you. So, Tamida, hope you had a great time.
Yes, I did.
Yeah, that's just what we do across board. We're passionate about our subject. Um, we tend to put in all our energy towards it. We don't just do it because of the time. Yeah, and that's what I want you to see across the lessons. We don't just do it across the time. So when we say 2 hours, we say 3 hours. When we were saying 1 hour before, now you see that 1 hour was not enough.
Yes.
Have you seen it?
Yes.
No, it was not enough. When I was saying it's not enough because there's a lot of things that you need to cover and the energy they have to put in. So if you're telling them 1 hour, you're simply telling them that they should do magic, And so yeah, again, just so all the things he has said, the materials is going to send you. It's always good for you to prep yourself ahead of the class. The questions you can handle yourself. Try to attempt all of them. The ones you can do them. If possible, you can also send.
Okay.
Right? You can also send the ones you've done to him on the platform. I think what I would do is I would create an assignment, but it will not be a due date. I will do that now. I'll create an assignment. It will not be. It will just be practice work, right? Practice work where you can submit it there and properly label it. This is the practice work for molecular something and all the things, and you can see it from there and check it. This is correct. This is correct. This is correct. This is good. This is good. This is good. This is not good, and that gives him an idea of how well you're practicing. Because again, saying that you've practiced is one thing, but when we see the proof that you've practiced, it makes it it makes it easy. It makes it easy. So I would do that. I would create that now. Assignments where you can be able to upload the works that you've done on the platform so that he can go through them and he can be able to assess your work. Okay.
All right. Yeah, that's fine.
All right. So again, please practice. If you have any question, bring them to class, send it to the platform, and we would definitely attend to you. Okay.
Okay. All right.
Any question?
No questions, sir.
All right. Have yourself a wonderful day.